to the next session on fluid mechanics. In this session, we are going to discuss the numericals of capillarity. The expression of capillary rise and capillary fall is what we have discussed in the previous class. So based on the formulas that we got from the derivation, we are going to discuss some numericals now. Calculate the capillary rise in a glass tube of 2.5 mm diameter when immersed vertically in water and mercury. So the first data given is the diameter of the glass tube, that is 2.5 mm. I'll convert this into meter. It is 2.5 into 10 raised to minus 3 meters. So it is immersed in water and mercury. So I have to calculate the capillary rise, that is the value of H. Take surface tension for water. This is the value given. So I write down sigma for water is 0.0725 Newton per meter, and for mercury it is given as 0.52 Newton per meter in contact with air. The specific gravity for mercury is given, it is 13.6. So when we know that specific gravity is 13.6, I can calculate rho for mercury will be 13.6 into 1000. This is the rho for water. So this is 13600 kg per meter cube. If you want, you can still write down rho for water is 1000 kg per meter cube. And angle of contact for mercury is given, that is the value of theta for mercury is given as 130 degree. So I want to calculate capillary rise and capillary fall, that is the value of H for rise and fall. So when I have to calculate the capillary rise for water, so the first one is capillary rise for water. Here the value of theta we have already discussed, this is going to be 0 degree. For H, the formula is 4 sigma cos theta upon rho g d. So this will become nothing but H is equal to 4 sigma upon rho of water g and d. So this is also for water. We will write here cos of theta is equal to cos of 0, which is equal to 1. So this cos term is gone. So when I substitute, this becomes 4 into sigma for water is 0.0725. Rho of water is 1000. G is 9.81. And the value of diameter is given 2.5 into 10 raised to minus 3. So the value of H turns out to be 0.0118 meter. So this is the first answer. And the second thing that I want to calculate is the capillary fall for mercury. Again, I'm going to use the formula of H, which is 4 sigma cos theta upon rho g d. So cos theta is going to be, this is sigma mercury, this is cos of 130 degree. Here we have rho of mercury, g and d. So when I substitute, this is 4 into 0.52 cos of 130 and rho is 13600, g is 9.81, d is 2.5 into 10 raised to minus 3, because it's the same capillary which we are using for measuring of rise for water and fall for mercury. So that's why the value of d is same. So here I get the answer as minus 0.0046 meter. This is the value of h. If you have to interpret the value of h, which is showing negative sign, you can just write here or h is equal to 0.004 meter, and negative sign indicates fall of mercury level. So every negative sign actually has an interpretation. It doesn't mean that the value of height has gone negative. It just indicates that there is a fall of mercury level in the capillary tube. So that completes one numerical. Now let's go to another one. Calculate the capillary effect in millimeters in a glass tube of 4 mm diameter. Again, the value of diameter is given, that is 4 mm. This is 4 into 10 raised to minus 3 meters when immersed in water and mercury. So again, we are solving a similar type of numerical. The temperature of liquid is 20 degrees Celsius, and the values of surface tension for water and mercury at 20 degrees Celsius in contact with air are given. So the first one is the value of sigma for water, that is 0.073575 Newton per meter. Sigma for mercury is given as 0.51 Newton per meter. The angle of contact for water, we know it is 0, and theta for mercury is 130 degree. The density of water is given as 998 kg per meter cube. So we need to calculate the value of H for rise and fall again. So when I start solving, I'll solve for capillary rise. Here the value of sigma for water is given. Theta we know is 0. Rho for water is 998. G is always 9.81. And diameter is 4 into 10 raised to minus 3 meter. So I think now you can solve. You'll get the value of H as 7.51 into 10 raised to minus 3 meters. So just substitute and you'll get the answer. Next I'll solve for mercury. When I solve for mercury, the formula is again 4 sigma cos theta upon rho GD. This will become sigma for mercury. This is cos of 130 degree. Rho of mercury, G and D. Now just be careful when you are solving here. You are going to use rho of water, which is standard value. So when I solve, I can use the value of rho for mercury as 13.6. That is specific gravity for mercury into 1000. This is 13600 kg per meter cube. Now at this stage, even if you use 998 in the exam, because it is given as 998, it should be considered. The reason is some people still say that since it is at 20 degrees Celsius and we are calculating, it should be that way. Or else, this is just a standard way of solving, wherein I am using the value of specific gravity as 13.6, which is a standardized value. So I have taken this as 1000. You can also take this as 998. You will get a very close answer. So when you substitute now, you will get the value of H as minus 2.46 into 10 raised to minus 3 meter. This can also be converted as 2.46 mm. And if you want to write H in terms of a positive value, you can just say that the negative sign indicates capillary fall, or this fall value can also be written as depression. Let's take up the last numerical. The capillary rise in the glass tube is not to exceed zero point 0.2 mm of water. So the given data is of H now, which is zero point 0.2 mm of water. So this is in terms of meter, 0.2 into 10 raised to minus 3 meter. Determine its minimum size. Now, when you talk about size, it could be the diameter value that is being asked. Given that surface tension for water, sigma is given, it is 0.0725 Newton per meter. We know the value of theta is going to be 0 degree. So I have to find the value of D. We know that H is equal to 4 sigma cos theta upon rho GD. Here the value of H is 0 0.2 into 10 raised to minus 3 is equal to 4 into sigma is 0.0725 cos theta has already become 1 upon rho for water is 1000, G is 9.81, and I do not know the value of D. If you solve this, you'll get the value of D as 0.148 meter. So these are few numericals on the topic of capillarity. It is just to clear your idea about the formulas that we have derived in the previous session. So with this, I end the session. I hope you have understood the numericals on capillarity. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.